In our previous class, we talked about quadratic functions written in vertex form. Not only did we talk about that, we also talked about a lot of the different characteristics that any quadratic will have, and today is just an extension off of that. The main difference between last class and today's video is now we're going to be talking about standard form. Standard form is not as obvious and clear-cut as vertex form, where we could easily get the vertex and know all these different min, maxes. Standard form gives us the same information, it's just a little bit more discrete. It's hidden within the problem. The equation for standard form, or in standard form, is f of x equals ax squared plus bx plus c. And if you notice, the main difference between standard and vertex form is standard form does not have parentheses. It's got three separate terms. A, B, and C are all going to be some numbers that vary from problem to problem. And the only thing here is it says A cannot equal 0. If A was 0, we would have 0x squared, and that whole part would reduce down to 0. So it would end up being a linear function. So A can be any number, positive, negative, fraction, decimal. It just can't equal 0. Like I mentioned before, all the information of this graph is going to be hidden within standard form. So when we look at y equals 2x squared plus 8x minus 2, we cannot tell what the vertex is right away. It's hidden, and there's a little formula we're eventually going to talk about of how to find the vertex. But it does give us some key information. Our a value, which in this case is 2, is going to still tell us whether the graph opens up or down. So a, if a is greater than 0 or a positive number, the graph is going to open up, which means we're going to have a minimum point. On the next page, we're going to talk about how to find the vertex using a graphing calculator. So I'm going to show you guys on the TI-84 and 83s how you could plug that equation in and easily get the vertex. I'm going to cross this idea over here out. I don't want you guys really using the table because there's a quicker and more efficient way to get it using a graphing calculator. Alright guys, so I'm going to go ahead here and show you how to use the graphing calculator to find most importantly, the vertex. So for this problem, the first thing we're going to do is go to y equals on both of our calculators. I've already typed it into the TI-84. The TI-83 is a little bit more difficult. When we type in the negative, you got to make sure you use the negative sign at the bottom. So negative 3x. Now to get a square, you're going to use the up arrow and then a 2, and then you're going to type the rest of it in. So minus 4x and then plus 6. All right, make sure your plot 1 is turned off. Notice how both my calculators, plot 1's turned off. Next thing we're going to do is graph it. So we're going to hit zoom, and we're going to click number 6 because that's zoom standard. That gets us a pretty good spot around the origin. So for both of these, we have a U-shaped graph that opens down, which we could have predicted. Our goal is to find the exact vertex. So on both these calculators, we're going to do the same thing. We're going to hit second, and then we're going to hit calc. And we are now trying to find a maximum. And same thing over here, so second, calc, option 4 for maximum. Now, left bound means we must be left, and I know the lighting's not the best, but our cursor must be left, so anywhere on this side of the vertex. I'm going to go ahead and hit enter. Over here, I'm going to do it a little bit closer and hit enter. Right bound means I must go to the right of the maximum point. So right there, I'm about at the max. I'm going to go a little bit right for both of these. And I'm going to hit enter and enter. And it's going to say guess. And I'm going to immediately hit enter one more time. And both of these end up telling me that the maximum is negative 0.6 repeating and 7.3 repeating. So if you look at your answer choices, every one of those answers is still in play when it comes to the vertex part. The axis of symmetry is x equals the x value, so it's automatically got to be either choice A or C, and then the maximum value would be 7.3 repeating, and the range would be y values less than or equal to. So our correct answer here is part C. All right, this page talks about all the key notes that we need to write down for a standard form equation. So each one of these little bullet points here is something that you should write down. Okay, they are all very important. The first one there says the graph of f of x equals ax squared plus bx plus c, a cannot equal 0 is a parabola. That's just our standard form. A is greater than 0, the parabola opens upward. A is less than 0, the parabola opens downward. Same old. The first new thing is the axis of symmetry. The axis of symmetry is the line x equals negative b over 2 times a. So that means if we take our b value and our a value and plug it in and simplify it down, that's going to give us our axis of symmetry. Now that's really important because we know that the vertex is somewhere on that axis of symmetry. What we're then going to do is once we have this number, we're going to plug it back into the original function and simplify and solve for y. That's going to give us the actual ordered pair. So we're going to find the axis of symmetry and plug that number into our function, and that's kind of what this is saying. It's saying plug that number into our function. Lastly, and probably the easiest, I would say, is the y-intercept of a quadratic equation in standard form is always 0 equals c. That is always the x-intercept. So whatever the number at the end, the constant term is, that's going to be the y-intercept. The reason that is because if we plugged in 0 for x, and if you just look, I'm going to point to it, if you plugged in 0 for x in these two spots, this whole part would simplify. So 0 gets plugged in and you would get a y value of whatever c equals. So 0 comma c is always going to be the y-intercept. When graphing at a standard form, the steps are a little bit different. We cannot start with the vertex like we could in vertex form. So the first thing is to identify what a, b, and c are. A is your coefficient in front of x squared, so it's going to be a 1 here. B is always the coefficient in front of x, which is 2, and c is always the constant, the number by itself, so that's just positive 3. First thing we're going to do is use our formula, x equals negative b over 2a, and we're going to plug in b and a and simplify. So we would plug in 2 for b and 1 for a. We would have negative 2 over 2 times 1, which is 2, which simplifies down to negative 1. So once we get that, we're going to go right to our graph and draw that vertical line through negative 1 on the x-axis. That's our axis of symmetry. Now, our second step is to find the actual vertex. So what we can do is we're going to take that number, which is negative 1, and we're going to plug it into our original equation for x. So we would have negative 1 squared plus 2 times negative 1 plus 3. Negative 1 squared is 1. This would be a negative 2. 1 minus 2 is negative 1 plus 3 gives us 2. So we plugged in negative 1 and we got 2. That means that point is our vertex. Next up is to plot the y-intercept. The y-intercept is always 0 comma c. So 0, 3 is our next point. Last step is to flip that over the axis of symmetry, and we would be at negative 2, 3. And then finally, we just draw our U-shaped graph through those 3 points. This first problem here is asking us to identify the vertex. So the vertex is where the graph changes directions. So I'm going to put a point on there, which is right here. And the ordered pair for the vertex would be 0 comma negative 4. Next, they want to know the axis of symmetry. The axis of symmetry is always x equals whatever the x value of the vertex is. So here it's 0. Then they want to know what is the min or max value. So since this graph opens up, it has a min value of, and negative 4 is the lowest this graph will ever be. So when we're given the picture, we can easily give that information. Second question here is to graph. And again, it's written in standard form, so we go right away to labeling what a, b, and c equal. So a is 1, b is negative 2, and c equals 4. And we want to go right to our axis of symmetry, which is x equals negative b over 2a. And we got to be careful with our negative sign there. So we get x equals a negative negative 2, which would be 2, over 2, which simplifies down to 1. So that means our axis of symmetry is at x equals 1. So that's through the x-axis at 1. I'm going to label that. Now, we know that our vertex is going to be somewhere on that axis. So that means its x value has to be 1. So I'm going to take 1 and plug it into my original equation for x. So y equals 1 squared minus 2 times 1 plus 4. Go ahead and simplify that. 1 minus 2 is negative 1 plus 4, and that gives me 3. So 1, 3 is going to be my vertex. Now, to get my next point, I'm going to go right to my y-intercept, which is always 0, comma, c, and c is 4. So 0, 4 is my next point. We're going to label that. We're going to flip that point over, which would be at 2, comma, 4. And the last step is to draw the U-shaped graph through those 2 points, or through those 3 points. Now, I will ask you guys to give me the domain and the range. So the domain is all real numbers, and the range is y values since it opens up greater than or equal to 3. Next one here, again, we're asked to graph something out of standard form. So I'm going to jump right into x equals negative b over 2a. So negative b is negative 3, so we got to be careful there, over 2 times negative 1. So a lot of negative signs here. So we get a positive 3 over a negative 2. So that's negative 1.5. It doesn't matter if you write it as a fraction or a decimal. So negative 1.5 would be right in the middle here. This one's going to be a little bit more difficult to show. So our AOS is x equals negative 1.5. Now we're going to take negative 1.5 and we're going to plug that in to find out what our y value of the vertex is. So y equals negative. I'm going to use the fraction here, negative 3 over 2. Whatever you guys are more comfortable with is fine. So we get y equals, now this is going to be a negative 3 over 2 squared. When you square a fraction, you are just squaring both numbers. So that's going to be 9 over 4. And then when we have a whole number times a fraction, we multiply across the top. That's really 3 over 1. So that's going to be a positive 9 over 2 plus 6. So we get y equals negative, and I'm going to convert these all to decimals now just because I think it's easier. So this would be 2.25 plus 4.5 plus 6. So that gives us, so negative 2.25 plus 4.5 would be positive 2.25 plus 6. So y equals 8.25. So now we're going to plot that point, which is negative 1.5 comma 8.25, which is like right about there. As long as you put the label next to it, so negative 1.5 comma 8.25. As long as you label it, that's fine. Next up is the y-intercept, which is 6. So, and we're going to flip that over. And the only thing we have to remember here is that 0, 6 point is 1.5 away. So we got to flip it equal distance on the other side. So that's going to be at negative 3 comma 6. Again, connect those points with a V-shaped graph, with a U-shaped graph. This graph opens down, and we would have known that from the beginning because we see that our A value is negative. Last thing, domain and range. and the domain would be all real numbers, and the range would be y values less than or equal to 8.25. Last question for this video is to do a little error analysis to figure out what's incorrect with this problem. So you're given y equals 2x squared minus 4x minus 3, and we're given this graph over here on the right. We want to find the issue. So first is we know it should open up because this 2 is positive, and it does. We know the y-intercept should be -3, and right there we know something is wrong. The y-intercept should be -3. So let's go ahead and see if we can fix this guy's mistake. So first thing is let's check his axis of symmetry. X equals -b, and right there I see an issue. We should have a -4. So I'm going to do the right work below. X equals -4 over 2 times a, which is 2, which would be 4 over 4, which would be 1. So right there, our axis of symmetry should be over here at x equals 1. And our vertex should be, we should be plugging 1 in, not -1. So we would get y equals, this would, 1 squared would be 1, 1 times 2 would be 2, 2 minus 4 minus 3, 2 minus 4 would be -2, minus 3 would be -5. So 1 comma -5 all the way down here would be our vertex. And then we would have 0, -3, and we'd flip that over and have 2, -3 as our other point. So I know this doesn't look the best, but you guys get the idea.